Okay, here's the second part in this discussion on scientific method. It's the difference between a law and a theory. Hypothesis, law, and theory is misused quite a bit in everyday language, especially you'll see it in media or politicians saying, well, that's just a theory. Actually, for something to be a theory, scientists doesn't say that until they have quite a bit of evidence to support it. If you don't have a lot of evidence to support it, but it's just something that makes logical sense, that's a hypothesis. Okay, so atomic theory has an unbelievable amount of evidence that supports it. The theory of evolution has an unbelievable amount of evidence to support that. And theories are models that just explain stuff. Now, a law is something that's a little bit different. Now, people have this idea that you have a hypothesis, okay, gather enough evidence and it becomes a theory, and then at some point, once you get enough evidence about a theory, it becomes a law. That's not actually how it works. Laws are different than theories. Laws are things that describe events that occur in our natural universe, and they don't necessarily have to have an explanation. So, for example, gravity. Gravity just is. Any two objects that have mass have some kind of mysterious attraction for each other. We don't really know why, but there is no exception to the law of gravity. So we've had it for quite some time. Let me give you a question. So hopefully you can read that. Let me make that a little bigger. All right, so hopefully you can read that. Here's a good place to pause. Make sure you went through these. All right, so let's take a look at these things individually. The total entropy of, that's supposed to be of the universe, so I got a typo right there, is constantly increasing. That's actually a law of thermodynamics. One of the things that we do a lot of our chemistry and physics is on the assumption, we've never found an exception to it, that the sum total amount of disorder in the universe is always increasing. Okay, mass is conserved in chemical reactions due to atoms not being created or destroyed, but simply rearranged. Okay, this is actually an explanation of the conservation of mass law. I guess that won't hurt anything. So that's not a law. We have a conservation of mass law, is just matter is not created or destroyed. When you start getting into these atoms rearranging and stuff, now you're getting into the model that explains that, which is part of atomic theory. All right, there is an invisible field that makes up the universe, and all matter has an attraction for this field. Okay, that is an actual theory that we have right now. This is the kind of thing that might become a law if we find enough evidence and there's no known exceptions to it. But there's this thing they're studying right now called the Higgs field, and anything that is matter has to have an attraction to that Higgs field, but we can't detect it with any of our senses. So, right now that's a theory. Electromagnetic waves can travel through the vacuum of space. That's really just kind of a statement. That's what electromagnetic waves can do. That's not a law. All right, so laws are things that describe natural events in our universe with no known exceptions. They don't have to have an explanation. Theories are models we use to explain stuff, and they have to have a lot of evidence to support them. Okay, a hypothesis is just something that makes sense and is logical based on the facts that we have, but we don't necessarily have enough evidence to support that they're a real thing. All right, so that's that part.